So this is going to be the last half of the test 3 review video. Make sure that you know how to do the different methods. So 26 and 27, I tell you I want you to use the addition method. So remember what we're looking for in all of these methods is we're looking for the point or points that they have in common. Okay? So you're looking for your answers to look like points when you're finished. So the addition/elimination method has you eliminate one of the variables by multiplying one or both equations by something so that one variable will go away. So I'm going to try to make both of these 6, but I'm going to make one of them positive and one of them negative. So I'm going to multiply this one by 2, and I'm going to multiply this one by -3 because I want one to be positive and one to be negative. So this is going to give me 6x minus 8y equals 22. Make sure everything gets multiplied by 2. And likewise here, make sure everything gets multiplied by -3. So this will be negative 6x minus 9y equals 12. So if you add those, you'll get negative 17y equals 34. And then we'll divide both sides by negative 17. Be careful of your signs. So I end up getting y equals 2, negative 2. I just said be careful of your signs, and I almost missed it, right? But now you need to find y or x. And you go back to the original, and it doesn't matter which of the two you use, just pick one of them. So I'm going to use this equation. So 2x plus 3 times -2 equals -4. So I'm going to add 6 to both sides. So 2x equals 2. And then divide both sides by 2. So x is 1. Okay. Oh, by the way, so let's not actually circle it like this, because how I want you to write your solution in the end, it's fine to have them separate, but in the end I want you to write it like this. So the solution then is the point 1, -2. Okay, and remember, you can check any of these by plugging them in. And plugging it into both equations, right? Because it should work for both. All right, so same process on number 27. So 3x minus 2y equals -5, and 4x plus y equals 8. So I would probably notice that I think it'll be easier to get rid of y first this time. So I'm going to multiply this equation by 2. Notice I don't need to multiply this equation by anything. Okay, I can just leave it alone. So that's going to give me 3x minus 2y equals -5, and 8x plus 2y equals 16. Remember, the point of this method is always because one variable should be eliminated. So if it's not being eliminated, you're doing something wrong. And then divide by 11. So x is 1. So don't stop here, right? We have 2 parts we need to find, so let's find the other one. So now let's find y. And again, it doesn't matter which equation you use, just pick one of them. So I'm going to take the second equation because I think y looks pretty simple here. So it's going to be 4 times 1 plus y equals 8. Subtract the 4 from both sides, so it looks like y is 4. So the solution then that can be checked by plugging the numbers back in is 1, 4. Okay, so typically the addition/elimination method is usually a student's preferred method, but you definitely need to make sure you can do the system of equations using the other methods as well. So let's move on to substitution. Okay, so when you have substitution, so x plus 2y equals 2, and -4x plus 3y equals 25. So in substitution, you want to isolate one of the variables and plug it into the other equations. So you want to get a variable all by itself. So it looks like that's going to be the easiest thing to solve for. So I'm going to subtract 2y from both sides so that I have x by itself. So notice that I get here x equals 2 minus 2y. Well, the point of substitution is to take this equation that equals x and plug it in for x. Okay, so rather than negative 4x plus 3y equals 25, we're going to have negative 4 times this plus 3y equals 25. Okay, so now we'll distributive property this. Notice we're down to one variable, so that's going to be helpful. So this is going to be negative 8 plus 8y plus 3y equals 25. And then if I add like terms and if I move the 8 over, so I'm going to do that in kind of one step here. I'll get 11y equals 33. So divide both sides by 11. So I get y equals 3. So now let's find x. And again, just pick the easiest of the two equations. So I'm going to pick x plus 2, y equals 2. So it's going to be x plus 2 times 3 equals 2. So subtract 6 from both sides, watch your signs, but you'll get x equals negative 4. So the solution, make sure you always go x comma y, is negative 4, 3. Okay, and again, you can check this, right? Plug it back in to check it. You should know, for most of these system of equation problems, you should know when you move on that you for sure did it right, because hopefully you have checked the answer. All right, so we have y equals 3x minus 5, and we have 21x minus 35 equals 7y. Notice this is like made for substitution, right? Like we already have y equals something. So we don't even have to do any work to really get to that point. So we're going to take this and we're going to insert or substitute it in for y. So this is going to look like 21x minus 35 on the left. But in place of y on the right, I'm going to put in 3x minus 5. So you might notice something a little strange about this one. So we're going to get 21x minus 35 on the left, but we're also going to get 21x minus 35 on the right. So when you try to kind of simplify, you notice you're actually going to get the x's gone as well, or eliminated. So you actually get negative 35 equals itself, right? Which is a true statement. And when you get a true statement, it means that you have infinitely many solutions. So what I also want you to say in a problem like this is it's actually any point on the line y equals 3x minus 5. What it means is it's not every point. It's not the same to say all real solutions, but it's infinitely many of them. Okay? So essentially, if you remember what we did in class, it's the line that lies right on top of another line, which means they share an infinite number of points. They share all the points on their common line. All right, so number 30, I gave you a choice. So you might have an occasional question on the test where you're given a choice on how to solve it. So just like the last problem was kind of set up to be a perfect substitution problem, I think this problem is set up to be a perfect addition problem or elimination problem. So let's say I want to get rid of x, so I'm going to triple everything because that'll give me a 6 where I want it. So I'm going to get 6x plus 12y equals 9, and then I'm going to try to add that to the second equation. But notice when I tried to get rid of x, I actually also got rid of y, and I end up getting 0 equals 17, which is not a true statement, right? 0 is not equal to 17. So this is a false statement. And when you get a false statement, it means no solution at all. If you'd like, you can use the alternate word for no solution, remember, which was inconsistent. So the alternate term for infinitely many solutions, remember, was dependent. So you can use either one of those. So notice in both cases we got rid of both variables, but this one was a true, which means it was infinitely many solutions. This one was not, so it was a no solution. All right, so 31. 3 variable systems. So 3 variable systems are not that much more difficult, but they are a little more time consuming because there's more stuff to try to figure out. Okay, so what you want to do is you want to combine two different sets of two equations, and you want to decide which variable you're going to eliminate. So you get to choose, but I'm going to choose, and I'm going to eliminate y first. It's helpful sometimes if you write down what you're going to do so that later on you don't get lost in what you were trying to accomplish. So I'm going to line up the first and second equations. And I'm going to do just what I set out to do. I'm going to eliminate y. Okay. So notice, I really need that to be a 2 if y is going to get eliminated. So I'm going to multiply by 2. And I'm going to see what happens. So I get 8x minus 2y plus 4z equals 22. And I get x plus 2y minus z equals negative 1. So just like I'd like, the y gets eliminated, right? So I get 9x plus 3z, be careful of your signs, equals 21. Okay, so I'm going to circle that, but it's not my final answer for sure. So I have one equation with two variables. Okay, so now my second goal is to combine another pair and get rid of the same variable. So I'm going to line up the second and third equations this time. Notice they're actually really close to being what I need for y to eliminate, right? I just need one of them to be negative. So it really doesn't matter which one you decide. But I'm going to multiply this one by negative 1. So I'm going to get negative x minus 2y plus z equals 1. And 2x plus 2y minus 3z equals negative 1. So that's going to go away, right? Careful of your signs. This is going to be x minus 2z equals 0. So I'm going to circle those two. Okay. So notice we got rid of y both times, and now I'm going to combine these. And then I'll be able to get my answer from there. Okay. So now I'm going to line up 9x plus 3z equals 21 and x minus 2z equals 0. And I'm going to try to see if I can combine those together. So notice that it'd be nice if maybe both of these were 6, right? So I'm going to double this one. I'm going to multiply this one by 3. Note, I already have a positive negative, so I don't really need to worry about that. So I'm going to get 18x plus 6z equals 42. And then I'm going to get 3x minus 6z equals 0, because anything times 0 stays 0. So note that I have 21x equals 42. And then I'm going to divide both sides by 21. So finally, all my hard work paid off, right? I get one of the three answers, x equals 2. So now I just need to find the others. Okay, so I'm going to use one of these equations to find z next. So now I'm going to find z. And then after that, I should be able to find my last one. So this is x minus 2z equals 0. So I got 2 for x, right? So minus 2 times z equals 0. So if you subtract 2, just be really cautious of your signs. Usually those are the biggest errors here. And then if you divide by negative 2, then you'll get that z is 1. And then last but not least, let's finally find y. So take any of the original equations. I'm going to take the second one because it's the smallest in number. So x plus 2y minus z was negative 1, and let's plug in what we know. We know x is 2. We don't know y. We know z is 1. So 2 minus 1 is 1. So if I want to move all of that over, I'm going to subtract 1 from both sides. So 2y equals negative 2. And then divide both sides by 2. So y equals -1. So I'm going to squeeze this in wherever I can. The solution then in x, y, z order was 2, comma, -1, comma 1. Okay, so I've said this before in class, but I think there's a difference between hard and tedious. I think this is tedious. It takes a lot of time. It takes some paper, but I don't think it's too difficult for you to do. Okay. Okay, so let's look at Cramer's rule, and then the rest of the problems after the next couple are going to be all matrix problems. So Cramer's rule, note that on the review itself, let me slide this, I'm going to give you this on the test. Okay, so you're not going to have to memorize kind of what the order of the letters is, but you are going to have to know how to do the determinant. So I'm going to show you what I mean by that when we look at the next two examples. So 32 is 2x plus y equals 3, and x minus y equals 3. Okay, so the first thing you do with Cramer's rule is you find 3 different determinants. One of them is called d, one of them is called d sub x, and one of them is called d sub y. Okay, remember that these are always in A, B, C order. So this is like your A's, your B's, and your C's. Okay, so for the D determinant, you would do just what your formula kind of hint says. You're going to do A's followed by B's. And then remember, you need to remember how to do this. So you do this times this minus this times this for any determinant. So you're going to do 2 times -1 minus 1 times 1. So -2 minus 1 is -3. For d sub x, it is the C column followed by the B column. So it's going to be 3, 3, 1, -1. So 3 times -1 minus 3 times 1. Make sure you do this way minus this way always. Okay, so you should get -6 here. And then this one is going to look like A's followed by C, so it's going to be 2, 1, 3, 3. So it's going to be 2 times 3 minus 1 times 3, or 3. So the solution is that x is going to be this one over this one. So x is going to be -6 over -3, or 2. And then y is going to be the d sub y over the regular old d. So the solution then, again, which could be checked like all these system of equations pretty much can be, is 2, -1. All right, last Cramer's rule question. So we have 4x minus 5y equals 17, and 2x plus 3y equals 3. So again, we need our determinants. So we've got d, d sub x, and d sub y. So d is A's followed by B's, so it's going to be 4, 2, -5, 3. So 4 times 3 minus 2 times -5. Make sure you keep your sign straight. So that's going to be 12 plus 10, or 22. D sub x is C's followed by B's. So that's going to look like 17 times 3 minus 3 times -5. So that would be 51 plus 15, or 66. And then d sub y is A's followed by C's, so 4, 2, 17, 3. So 4 times 3 minus 2 times 17. So 12 minus 34 would be -22. So your x is going to be this over this. 66 over 22 is 3. And your y is going to be this number over the d determinant, so you're going to get -1 there. So then the solution, which one more time we can plug in to check, would be 3, -1. Okay, so Cramer's rule is just a way that kind of uses matrices in a specific way in order to find system of equations solutions. All right, so a good rule of thumb would be to make sure you can do all the methods, okay? So remember we did an activity in class where you had to do one problem and do it 4 different ways. And so that's a good way to practice this kind of stuff because there'll probably be a method that you're least comfortable with, and you'll need to make sure that you fix that before you take test 3. Okay, so remember with these matrix problems, you are striving to get the matrix reduced so that you can find the solution. So you first write your numbers in columns. Remember, these are augmented matrices, so this bar means equals. So your goal, remember, is to get 1, 0, 1, 0. Okay, the 1s go in a diagonal, 0s everywhere else. Okay, so notice you always start from column number 1 and you always start with where the 1 should be. So notice, like, we already have a bonus, right? The 1 is already what it should be. Okay, so we move on to this, and we'd really like this to be a 0. Okay, notice we don't even have to work that hard to make this a 0, right? And remember, you list the row that's changing second, so I'm just going to say row 1 minus row 2. So that means row 1 is staying steady. So 1 minus 1 is 0. 3 minus negative 5, careful of your negatives, would be 8. 11 minus negative 13 would be 24. So that wasn't too hard, right? And we got the first column looking good. So now we move on to the second column, but more specifically, we start with where the 1 should be. So this is where the 1 should be because it's in a diagonal. So we really want a 1 there. Okay, so we're going to do the reciprocal of that number. You get a 1 by multiplying by the reciprocal often. So notice this is not going to change row 1 again. But row 2 is just going to get divided by 8. So notice, like, we're almost there, right? We're good here, here, here. The only thing left is this one. So we'd really like this to be a 0. So we get 1s by multiplying by the reciprocals. Okay, we get 0s by adding the opposite sign. So you could add a negative 3 to a 3 and it would be 0. So I'm going to do negative 3 times the second row plus the first row. Remember, again, whatever's listed second is the row that's changing. So negative 3 times 0 plus 1, that's still 1. Negative 3 plus 3 is 0, just like we wanted. And then negative 3 times this would be negative 9. Plus 11 would be 2. So in the end, this solution is just what we're left with. It's 2, 3. Okay, and notice you could check that just like you could the other methods, right? We have 4 methods for solving 2 variable systems. Okay, we have addition/elimination, we have substitution, we have Cramer's rule, and we have matrices. Okay, so let's look at 35. Same kind of gist, but trust me when I say it's not enough to watch me do these. You're going to need to practice them on your own because it's different to try to come up with the changes yourself than it is to follow when I tell you what the change should be. Okay, so really make sure you practice that homework. It's the last homework section of the semester. All right. So the first thing is we start in the top left corner, okay? And we remember that we really want this to be a 1. Okay, so we use the reciprocal to get that. So we're going to do a half times row 1. Half would be the reciprocal of 2. So notice I'm pulling over what's not changing first, and then I'm just dividing by 2. 2 divided by 2 is 1. 3 divided by 2 is 3 over 2. 6 divided by 2 is 3. Okay, so this is kind of a slow process, but it just kind of systematically works one step at a time. So we got the 1. And now we are going to work on making this a 0. So you would make that a 0 by adding a negative 2. So we're going to do negative 2 times row 1 plus row 2. So we're going to get row 2. And actually, I did that wrong. Row 2 is the one changing, so I kind of quickly moved that over, right? But I actually need to do my changes first. It's row 1 that I can quickly move over, right? Row 1 is not listed second, so it's not changing. So negative 2 plus 2 is 0, just like we want. Negative 2 times this would be negative 3, plus negative 3 would be negative 6. Negative 2 times 3 would be negative 6, plus 6 would be 0. So notice we're slowly getting there, right? We're good here and here. So next stop is we want this to be a 1. Okay, so remember, you go on from column to column, fix the 1s first, and then the 0s. So we're going to do the reciprocal of negative 6, which is negative 1/6. So basically just divide everything by negative 6. So 0 divided by negative 6 is still 0. This is going to be 1. 0 divided by negative 6 is 0 again. So notice, every step we're getting closer to what we want, right? So last but not least, we want this to be a 0. So don't be fooled by the fact that this is a fraction. We don't need the reciprocal here because we are not trying to get a 1. We're trying to get a 0. So we actually need to do negative 3/2 times row 2 and add that to row 1. Because negative 3/2 is what we're going to add to 3/2 that's going to make it 0. So carry over your second row because it's actually complete if you look at it. And then negative 3/2 times 0 plus 1 is 1. Negative 3/2 plus 3/2 is 0. Negative 3/2 times 0 plus 3 is 3. So the solution, again, that could be checked, and I hope you will, on the test is 3, 0. All right, so x plus 2y equals 4. 2x plus 4y equals negative 8. Okay, so the first thing you want to do is you want to write it as a matrix. And just like before, you want to start your process. So notice, we already get this one for free, so that's nice. Okay, so we just start working on this, and we want a 0. So we're going to do negative 2 times row 1 plus row 2. Because row 2 is changing, row 1 is not. So we're going to do negative 2 plus 2, which is 0. Negative 2 times 2 is negative 4 plus 4, which is 0. Okay, so right here from class, I hope you remember that this means it's one of the unusual solutions. Okay, it all depends on what we go here or what we put there. So 4 times negative 2 is negative 8 plus another negative 8 is actually negative 16. Okay, so the problem is that this row is false or impossible. We can never have 0x plus 0y equal negative 16. That's not ever going to happen. It should actually equal 0. So basically, one bad row throws out the whole question, and it's just a no solution. So note, we were trying to solve, and we just got something janky for the last row, so we concluded that it must have been one of our special cases. And actually, I did these out of order. Sorry about that. So this is actually 37. So I'm going to put a star here so that when you watch it, I'm not going to redo the video just for that switch. But so let's do actually 36 now. These were so close that I just got them mixed up, honestly. So x plus 2y equals 4, and 2x plus 4y equals 8. So let's write this one as a matrix. So 1, 2, 4, and 2, 4, 8. Okay, so just like before, notice that the 1 is a freebie. We really want a 0 here. So we're going to do negative 2 row 1 plus row 2, kind of just like we did in the last question, because these are very similar numbers, or really just one number changed. So row 1 is going to stay. And then we're going to do negative 2 plus 2, which is 0. Negative 2 times 2 plus 4, which is also 0. And then negative 2 times 4 plus 8 is 0. Okay. Now this is not impossible. In fact, this is actually always true. Right? Like 0x plus 0y equals 0 would always work. Okay. So this is actually the opposite. This is actually infinitely many solutions. And remember, if you're watching this video back, you need to flip-flop 36 and 37. So infinitely many solutions, and I want you to know that it means that it's any point on this first line right here, on x plus 2y equals 4. It's not all solutions, it's just infinitely many. It's any point that qualifies here. So it could be the point 0, 2, right? Because if you plug in 0 and 2, you get 4. Okay? But it could also be the point 4, 0, because if you plug in 4 and 0, you get 4. And there is an infinite amount of pairs that would work. And any pair where you add them together in this way and you get 4 is a solution. All right, so the last two questions are 3 variable matrix problems. These do take some time. So just know that I won't go really heavy with these on the test. And so what I do sometimes to save time is I'll just give you some row operations to do rather than having to do the full-blown matrix solving part. All right, so first let's rewrite this as a matrix. So 2, 1, 2, 2, 3, negative 5, negative 1, 4, 1, negative 2, negative 3, negative 6. Okay, anything with 3 variables is going to be more tedious than the 2 variable ones. There's just more to do. So the first thing is, I really would like to have a 1 right here. But I actually can do a row swap and that'll get me my 1. So I'm going to row swap rows 1 and 3. So occasionally on the first step you might get lucky and get to have a row swap kind of help you out. It's a lot easier than doing multiplying by the reciprocal every single time. So when you can do it, it's a nice little bonus. Okay, so notice the 1 is where we want it. So then we move on to these zeros. Okay, and we do them just like we did the 2 variables. So I want to add negative 3 to make it a 0. I want to add negative 2 to 2 to make it a 0. So I'm going to have 2 instructions. So it's going to be negative 3 times row 1 plus row 2 to change row 2 to the 0. And then I'm going to have negative 2 times row 1 plus row 3 to change row 3 to a 0. Okay, notice that the row 1 is not listed second for either one. So it is not being changed. So negative 3 plus 3 is 0. Careful of your signs. Negative 3 times negative 2 is 6 plus negative 5 is 1. Negative 3 times negative 3 is 9 plus negative 1 is 8. Negative 3 times negative 6 is 18 plus 4 is 22. Negative 2 plus 2 is 0. Watch your signs again. Negative 2 times negative 2 is 4. Plus 1 is 5. Negative 2 times negative 3 is 6. Plus 2 is 8. And then lastly for this one, negative 2 times negative 6 is 12. Plus 2 is 14. So notice, we are moving along, right? We got 1, 0, 0. So now we move on to the second column. Okay, and the second column, you have to remember that the 1s are supposed to be in a diagonal. So actually, this is where we want the 1, and we actually already have it. So we got a little bonus there. We didn't have to work to get that. So now we move on to these, and we want zeros again. Okay, so what would you add to negative 2? That would make it a 0. It would be 2, right? And you would add negative 5 to 5 to make it a 0. So this one's going to look like 2 times row 2 plus row 1, because remember, I want to change row 1 this time. Okay, and then I do negative 5 times row 2 plus row 3, and that'll change my row 3. So row 2 pulls over because it is not being changed. So 2 times 0 plus 1, that's still 1. 2 plus negative 2, that's 0. 2 times this is 16, plus that is 13. 2 times this is 44, minus 6 would be 38. Negative 5 times row 2 plus row 3, 0 and 0, that's still 0. Negative 5 and 5 is 0. Negative 5 times 8 is negative 40, plus 8 is negative 32. And then lastly, 5 times, or 22 times negative 5 would be negative 110. So it doesn't hurt to kind of check yourself, but yeah, it's negative 110. So it's going to be negative 110 plus 14. So that's going to be sorry, my calculator's being janky. Negative 96. Okay, so I'm really almost there because this column's good. And so is the second. So now I just need to move on to the final column. And remember, always fix the 1 first. Okay, so this right here needs to be a 1. And who cares that it's a big number? You always get a 1 the same way. You multiply by the reciprocal. So I'm going to do negative 1 over 32 times row 3. That's going to leave rows 1 and 2 the same. But this is going to be a 1 and this is going to be a 3. So use your calculator if you want to, but 96 divided by 32 is 3. And they're both negative, so it's a positive answer. So I'm so close. Lastly, I need these to be zeros. So I'm going to use negative 13 to make that a 0, and I'm going to use negative 8 to make that a 0. So negative 13 row 3 plus row 1, and negative 8 row 3 plus row 2. Notice row 3 is not changing. Row 3 is finished. Hallelujah, right? So 0, negative 13 times 0 plus 1, that's 1. 0 and 0 is still 0. Negative 13 and 13 is 0. Negative 13 times 3 is negative 39, plus 38 would just be negative 1. And then 0 and 0 is 0. 0 and 1 is 1. Negative 8 and 8 is 0. Negative 8 times this is negative 24, plus 22 would be negative 2. So the solution, which could be checked just like back on number 31 when we had a 3-variable system, you could check the solution, but it's negative 1, negative 2, negative 3. Okay, so really, I mean, they are a little tedious, but in some ways I think this is actually less time consuming than the other method that we used in number 31. So just kind of make sure you know how to do maybe both ways. So the last question. It's going to look like this. So this looks like this is a matrix. So the first thing I'm going to do is I'm going to do a row swap again, because notice I can get the one where I want pretty easily that way. So I'm going to do a row swap between 1 and 3. If you can't do a row swap, though, remember you can always get the 1 by just multiplying by the reciprocal. But a row swap is definitely quick and nice. So the 1's good to go. So now I move on to these. And remember, I want these to be zeros. So I'm going to use negative 2 for this one and 5 for this one. So negative 2 row 1 plus row 2 to change row 2. Negative 5 row 1 plus row 3 to change row 3. Row 1 is not going to get changed at all, so I'm just going to pull that over. You want to come up with some structured process. So like I always pull over the row that's not changing first, and then I worry about the things that are changing. So back up here, negative 2 plus 2 is 0. Negative 2 times this plus 5, so it'd be negative 4 plus 5, or 1. Negative 2 times negative 3 would be 6, plus 2 would be 8. And then negative 2 times 5 would be negative 10, plus negative 1 would be negative 11. Negative 5 and 5 is 0. Negative 5 times 2 would be negative 10, plus 12 would be 2. And then this is negative 5 times negative 3 is 15, plus 1 is 16. And then negative 5 times 5 is negative 25, plus 10 would be negative 15. Okay, so far so good. So column number 1 looks good. And kind of like before, I get another bonus. Notice this looks good too, so I really just need to skip ahead and try to make these zeros. So notice they both need -2, right? So I'm going to say negative row 2, or -2 times row 2 plus row 1 to change row 1. And then I'll do the same, but add it to row 3 to change row 3. So row number 2 is not changing. So -2 times 0 plus 1 is still 1. -2 plus 2 is 0. -2 times this is -16, plus this would be -19. -2 times this is 22, plus 5 would be 27. And then let's see what I get here. So -2 row 2 plus row 3, right? So 0 and 0 is still 0. -2 and 2 is 0. -2 times this plus this is 0. So again, I'm getting something weird, and it all depends on what I get here as to what my conclusion is. So -2 times this is 22, plus this is 7. Okay, so kind of like before, this is false. This can't happen. So when we have something that is false or we can't happen and we're pretty sure we did everything else right, then it means that it's a no solution.